Hi there! Welcome back to GeeklyEDU. One of the main models in probability is today's topic, binomial distribution. Why is it so important? This is because most of the situations in real life has two outcomes, yes or no. And let's take an example with the vaccine trials. Here we have many binomial outcomes, if it works or if it does not, if it has secondary effects or not, and even if it was a placebo or the actual vaccine. It is important to identify when to use the binomial distribution, and remembering that this is a probabilistic model, and we need more than one trial. Therefore, we are going to use the binomial distribution when we have a number n of trials in a random process, and you only have two outcomes, success or failure. Success means that you get the outcome you are counting, and failure is when you get the second outcome, but it does not mean that failure is a negative event. In this kind of distribution, the probability of getting success or failure is the same in each trial. It remains constant. The probability of success is denoted with p, and the probability of failure is 1 minus p, denoted with q. You can also see that the addition of probabilities of success or failure is equal to 1. The results in each trial does not affect the next trial. Therefore, we have independent results. The events are mutually exclusive. That means that in each trial, you will have only one of those outcomes. You cannot get both at the same time and collectively exhaustive because those two outcomes are the only possible results. We will use a formula to get the binomial probability P of x that describes the probability of x successes in a number n of independent trials, being P the probability of success and Q the probability of failures. The first term is the binomial coefficient that can be also read as n choose x. This coefficient is the number of x combinations on a set of n trials. The exclamation point means factorial, that is the product of all positive integers less than equal to the given number x or n. I would recommend you to take a screenshot to these equations before getting to an example of the binomial distribution. Suppose that 67% of people do not get the flu in the winter season. What is the probability that 11 persons out of 66 get the flu? First, we have to be sure that this can be solved with the binomial distribution model. It is a random process with n equal to 56 trials, and we have two outcomes. Getting sick, that in this case it is the success, and not getting sick as a failure. Every person has the same probability Q equal to 0.67 of not having the flu. From this information, we know that this problem is solved with the binomial distribution. We will calculate the binomial coefficient by substituting the numbers and computing 67 choose 11. Using the formulas and substituting, we get the binomial coefficient. Now we are going to substitute the values in the binomial probability equation, but the probability of success P is missing. We know that the sum of Q and P is equal to 1. Therefore, P is equal to 1 minus 0.67 equal to 0.33. Substituting all the numerical values and computing the probability that 11 people out of 56 get the flu is equal to 0.00287, or this can be written also as 0.287%. we calculated the probability of exactly 11 people out of 56 getting sick. But in this case, we will calculate the probability that 3 or less persons out of 56 get the flu. For this, we must compute the probability for x equal to 0, 1, 2, and 3 out of 56, and sum the probabilities for each number of success. Following the same procedure as we did in the first example, we calculate the probability when x is equal to 0, substituting in the binomial probability formula and doing the same for 1, 2, and 3. Now, we have to sum these probabilities to get p of x equal or less than 3, being 6.76 times 10 to the power minus 7. If we calculate the probability to the different numbers of success from 1 to 56, we have that the probability distribution behaves as follows for the example when p is equal to 0.33. What other situations can be studied with the binomial distribution? Tell us in the comments below.
If you enjoyed this video, don't forget to subscribe and stay tuned.